Welcome to our next session. This is the second topic in Form 3, Approximation and Errors. So in this case, we are going to be working around approximations and errors. And in fact, when the next thing as usual, which is the specific objectives, the first objective is approximations and errors, or rather estimation and approximation. So estimation. So you remember, the only one thing that you need to remember is that these errors arise from estimations. As the name suggests, when you estimate something, that simply means whatever you get is not the accurate value. So it is an estimate value. So the difference between the estimate and the accurate value is the error. And that is why later we will say, or rather we will conclude, that error cannot be negative. Error is the margin of deviation from the actual value. So if the estimate deviates from the actual value by 2, then the error is 2. So it doesn't matter whether the estimate is more than or less than the actual value. As long as the difference between the two is a certain number, that becomes the error. So error is the measure of size between the actual and the estimate. So error cannot be negative. So the objectives, number 1, is estimations and approximations. The second objectives will be what we call now the absolutes, relative, and percentage error. And thirdly will be the propagation on errors, which is the climax of this topic, propagation of errors. So these are the things we shall be looking at throughout this topic, propagation of errors, and within this scope we shall be doing the basic mathematical operations, which is addition, subtraction, division, and lastly multiplication. So all this propagation will be tied to these three: absolute, relative, and percentage errors. So estimations. So when talk about estimation and approximations, estimation is that mathematical concept which will give you the estimate value or the approximate value and not the actual value. The basic types of estimations, or the various types of estimations, are 1, which is a very common one, rounding off. Number 2, truncation. Number 3, significant figures. So just but to discuss them briefly, when talk about rounding off, say for example, you have an example such as 23.457. When you're told to round off, say, to 1 decimal place, then you only need to check 1 decimal place, then to identify the next number. If it is 5 and above, you round off to the next number. If it is less than 5, then you leave it as it is. So here, if you're writing to 1 decimal place, rounding off to 1 decimal place, then the answer will be 23.5. Because this number here is 5, so it's 5 and above, so you round off. If you had, say, for example, 23.427, so here you notice that this number is less than 5, so the answer will be 23.4. So that is rounding off. That is obviously something very easy. We did that back in Form 1 and even primary school. So truncation. Now truncation, unlike in rounding off, you only need to focus on the number of decimal places that you're told. So if you're told truncate to 1 decimal place, let us take the same example here. So if you have 23.457, truncate to one decimal place. So only need to get one decimal place, then ignore the rest. We don't round off. You just leave the rest, irrespective of whether it's 5 and above, it's 5. As long as you have your the required number of decimal places, everything else you ignore. That is truncation. Significant figures, this one is easy. This is another concept which you must have come across in Form 1. But one thing that you need to know is that as you write to the required number of significant figures, say for example 4, 5, 7, if you are told to write this to two significant figures, so 1, 2, the next number is more than 5, so you have to round off kind of. So this will be 4, 6, but these are the numbers which comes after that number, you retain the 0. You don't just write 46, but 460. If you have 32, 48, write two significant figures, so 1, 2. This is less than 5, so you don't round off, so you have 32, then retain the zeros, 0, 0. You change the rest to be 0. And that is how you write a number to the required number of significant figures, maybe one decimal figure or decimal fraction, 4, 5, 7. So if you are told to write this to one significant figure, that will now change to, this is not significant, definitely, point. So 4, 0, point. This is more than 5, this is actually 5. So round off, that will be 0.500. So one key thing that you need to take note is that you must retain the zeros. After you round off or fail to round off, depending on whether the next number is 5 and above, you have to retain the zeros. You retain the zeros in the case of significant figures. Now all these, look at the first example here, the number was 23.457. The approximate is 23.5. So the difference between this approximate and the actual is the error. That is where errors come in, is the error. So when you round off a number, you get the error. When you round off a number, you get an estimate value, and the difference between the estimate and the actual is the error. That is how errors come in. But there is another dimension where errors come in, which is in measurement. So take, for example, construction or an experiment in the lab. When you construct, say a triangle, a rectangle, or whatever figure that you will construct, the values that you get as you measure, chances are whatever you get is going to be different from what another person gets and from what the actual value. There is going to be a deviation. Now, the levels of accuracy depends on your least unit of measurement. One person will measure to one decimal place, another one will measure to 2 decimal places, and another one will measure to the maximum mostly measurement is 2 decimal places. In that case, therefore, the level of accuracy will depend on your choice of the decimal places. And of course, the more the number of decimal places, the higher the accuracy. The lesser the number of decimal places, if you measure to 1 decimal place and another person measures to 2 decimal places, that person who has opted for 2 decimal places will be more accurate compared to the one who was chosen or was opted for 1 decimal place. So take, for example, if you measure a rectangle, 3.2, 1.75. So you notice the length has been measured to 1 decimal place, the width has been measured to 2 decimal places. So in this case, therefore, you will need to get the least unit of measurement. The least unit of measurement here is a 0.1 because it's 1 decimal place. So if you may convert that to millimeters, you get that is equal to 0.1. Here, 2 decimal places, that is equivalent to 0.01. So if you want to get the error in measurement, you take the least unit of measurement, 0.1, divided by 2 to get 0.05. So the margin of error here is 0.05. You take the least unit of measurement, divide by 2, which means the length will range between 3.2 plus or minus 0.05. So your maximum value for the length is 3.25 and the minimum value is 3.115. And the same case applies to the length, but now of the width, so for the width, however, will be 0.01 divided by 2, which is 0.005. So you have 1.75 plus or minus 0.005. So you get your maximum 1.755, and this is the other one will be minus 0.05. This is 1 point minus 0.005. That will be 1.745. So you have the limits. So your length, the width will, maximum value will be 1.755. The minimum is 1.75. But remember, this one is only in the case of measurement. Anything that involves measurement, the height of a rectangle, the length of a cube, the height of a cylinder, the radius of a cylinder, etc. So all this will require you to use the number of decimal places. If you are told it is measured to the nearest whole number, you use 1 over, because the number of decimal places in that case is 0. There is no decimal place, so you use 1 over 2. 1 decimal place, 0.1. 2 decimal places, 0.01, etc. So that is in the case of those which involves measurements. So that is in the part of estimations and approximations. Now, what is the effect of these estimations and approximations? So we will now focus on the absolute error, relative, and percentage error. Now remember, for absolute, relative, and percentage, absolute error, you take remember the example of a rectangle where you have the length and the width. You get the maximum value, the maximum, the upper limit of length and the width, and the lower limit of the length and the width. Which means, if you're looking for, say, the area of the rectangle, you will end up with the upper limit for the area and the lower limit for the same area. If you're looking for the perimeter, the same thing will apply. You will have the upper limit and the lower limits. And that now takes us to absolute error. Absolute error, which is equal to maximum minus minimum divided by 2. So if the question was about area, you get the maximum area minus the minimum area divided by 2. If it's about perimeter, you get the maximum perimeter over minimum P divided by 2. Volume, the same. Relative error. This is equal to absolute error divided by the actual. So the actual means, if you are talking about area, you'll get the absolute error divided by the actual area. If it's about perimeter, over the actual perimeter. If it's volume, over the actual volume. And lastly, percentage error. Which is equivalent to relative error times 100. So this is generally, in fact, the major parts of approximation and errors, but that is in the context now of propagation of errors. But these are formulas that you must remember, or rather relationships. Absolute maximum minus minimum divided by 2, relative absolute divided by the actual, percentage relative times 100. And now the next part, which is now the climax of approximation and errors, which is propagation of errors. So, as I said earlier, propagation of errors has 4 parts: addition, subtraction, division, multiplication. But we will not do the 4 parts separately. We are going to group them into 2 parts because the 2 categories behave in the same way. So the first, on one hand, we will start with the easiest, which is addition and multiplication. So if you are looking at, let's use our rectangle. This was a 2.3, 1.75. So if you are looking at this, we say that 1.75 plus or minus 0.05. So you get 1.755 and then 1.675. We confirm that 05 and 745. Then you have 2.3 length plus or minus 0.5, 0.05. So you have 2.35 and 2.25. So for addition, then we will have to consider perimeter. Then multiplication, we consider the area of the rectangle. But that is not important. The most important part is how now do you proceed. Remember, as you look for the absolute error, you take maximum minus minimum divided by 2. So in this case, for addition, so we said here we consider perimeter. So you will need to get the maximum perimeter. So maximum perimeter is 2 into maximum length plus maximum width. That means 2 into brackets maximum length 2.35 plus 1.755. That is the maximum perimeter. Then we need a minimum perimeter. That is 2 into minimum length plus minimum width, which is going to be 2 into brackets length 2.25 plus 1.745 minimum perimeter. And of course you will need the actual for the purposes of getting the relative error. So the actual is equals to 2 into, you just pick them as they are, 2.3 plus 1.75. So with this, you will get the maximum perimeter, the minimum perimeter, and the actual perimeter. So if you want to get the absolute error, you will now take maximum minus minimum divided by 2. You want to get the relative error, you take the absolute error divided by the actual, then percentage error, you just multiply by 100. For area, that is now multiplication. Maximum area is equals to maximum length times maximum width, which is 1.745 maximum width, 55. So we start with the length actually, 2.35 times 1.755. That is the maximum area. So you notice you're taking maximum times maximum. Minimum area, you take minimum length times minimum width. And lastly, the actual area, for the purposes of getting the relative error and later the percentage error, we take the actual area, which is, you take just the actual as they are, 2.3 times 1.75. So you notice in addition and subtraction, you take maximum, for the two dimensions. If it's length and width, you take maximum width, maximum length. If it's height and radius, maximum height. That is if it is addition and multiplication. It's maximum, minimum, The actual, that would be the same for both, for even in the case of the second category, division and subtraction. But we are in multiplication and addition. So you take maximum, minimum, minimum. That is in addition and multiplication. Now we want to see the difference between addition and multiplication versus division and subtraction. So, for division and subtraction, take the same example. We have, let's say, 2.3 divided by 1.75. Then in subtraction, you have 2.3 minus 1.75. We already have the limits for 2.3 plus or minus 0.5. So that was 2.35 and 2.25. Then you have 1.75 plus or minus 0.005. That's 1.755. And you have 1.745. So for division, if you want to get, whenever you divide two variables, the answer is called the quotient. So if you want to get the maximum quotient, you will take maximum divided by minimum. If you want to get the maximum difference, when you subtract, you take maximum minus minimum. So you notice they also behave in the same way. Division, maximum divided by minimum. Subtraction, maximum minus minimum. Then in minimum Q, minimum quotient, you take minimum, you interchange now, minimum divided by maximum. Then subtraction, again, minimum difference, you take minimum minus maximum. So maximum quotients, you take the maximum, so maximum of 2.3, that is 2.35 divided by minimum of 1.75, which is 1.745. Minimum Q, you take the minimum of 2.3, which is 2.25, divided by maximum of 1.75, which is now 1.755. So here you get the maximum, you get the minimum. So if you want to get the absolute error, you take the result here divided by minus the result here divided by 2, because absolute error is equals to maximum minus minimum divided by 2. So you take the result minus the result here, you divide by 2. If you're looking for the relative error, then you need to get an actual quotient, actual Q, which of course you take 2.3 divided by 1.75 as it is. The same case applies here. For maximum difference, you take the maximum of 2.3, which is 2.35 minus 1 point minimum, 1.745. For the minimum difference, you take the minimum of 2.3 which is 2.25 minus the maximum of 1.75, which is 1.755. So you notice it is the same thing. Division, subtraction behave the same way. Addition and multiplication again behave the same way. So that is how you categorize the propagation of errors. However, you need to take note that there are instances whereby we combine addition, subtraction, division. So you have to be specific about what you're doing. For example, if you're told, given that you have that 2.3, 1.75, let me phrase that question well. So given that A is equals to 2.3 and B is equals to 1.75. Find the percentage error in AB divided by A minus B. So in the numerator you have AB, which is multiplication. In the denominator you have A minus B. And then you now have the main concept being tested is division. AB minus A minus B. Division. So you have division, multiplication, and subtraction. So how do we do that? So one, you need to identify which is the main concept, which is the main mathematical operation. Is it division? Is it a subtraction? Is it multiplication? But from this, clearly the main is division. So given that the main is division, so you need to get one, the maximum Q. And we've said maximum Q in division, maximum Q for quotient is maximum divided by minimum. You also need the minimum Q for you to be able to get the absolute error. So minimum quotient is the minimum divided by the maximum. So with this, you should be able to get the absolute error. With the absolute error, you can get the relative error because here you can get the actual, you just replace directly. So the most important part is here, maximum quotient and the minimum quotient. So how do we get the maximum quotient? So numerator is maximum and the numerator is multiplication. So how do you get maximum in multiplication? So you take maximum in multiplication is maximum times maximum. You should be able to remember that. So maximum A times maximum B divided by denominator, we are looking for minimum. And the minimum is minimum minus maximum in subtraction. Minimum minus maximum to get the minimum. So you take minimum A minus maximum B. So this will now give us the maximum quotient. Maximum quotient. The next one is the minimum quotient. So minimum, numerator to get the minimum in multiplication, we take minimum A times minimum B divided by maximum difference. So to get the maximum difference, we take maximum minus minimum. So maximum minus minimum, A, B. So with that, now you can get the absolute error. You can get the absolute error because you have the maximum and the minimum. So maximum minus minimum divided by 2, you get the absolute error. And with the absolute error, you can get the relative error by dividing by the actual. And with that, you can now proceed on to get the percentage error, where you just take the relative error times 100. That is on propagation of error. So you need to take note of how you classify them. Addition, subtraction, addition and multiplication, division and subtraction. There is another part which is always going to be very common, whereby the errors do not involve measurement. So how do you get the limits. For example, you're told that there is an error of 2% in A, which is, and A is 2.3, 3% in B, and B is 1.75. So in this case, you will not look at the number of decimal places to get the least unit of measurement or to get the limits, because you're already given the limits. There is an error of 2%. That will give us the error, which means the error is plus or minus 2%. So the limits for 2.3 in such a case will be 2.3 plus or minus 0.002. You get the upper limit and the lower limit. For B, 1.75 plus or minus 0.003. You get the limits. So here you don't consider the number of decimal places, because we are already given the error. The error is 2% in each one of them. So you need to work with that percentage as it is. Another area which I have to mention before we conclude this topic is on this part. You're told the radius of a cylinder is 3.5 and the height is exactly 8. Find the percentage error in the volume of the cylinder. So the key word here is exactly. So if it is exact, that means there is no error in that measurement. So in that case, you'll only look for the limits in the height, in the radius, not in the height, because the height is exactly 8. There is no error in the height. So here, you take 3.5, so one decimal place, that means it's 0.1 over 2. You have 0.05, so it is 3.5 plus or minus 0.05. You get 3.55, 3.45. So there is no error in the height. So here you will work with height as you look for the maximum volume. So volume of a cylinder is pi r squared h, so 22 over 7 times r. So you're looking for the maximum, so you take 3.55 squared times height, 8. No limits, because it's exactly 8, so there is no error in the height. To get minimum volume, you take 22 over 7 times the radius, 3.45 squared times height, again 8. So to get the absolute error, you take maximum minus minimum divided by 2. Relative error, absolute error divided by the actual. So the actual V will be 22 over 7 times 3.5 squared times height 8. No limits. So this one is actual. So maximum minus minimum divided by 2 to get the actual. You divide again by the to get the absolute error. Divide by the actual to get the relative error. Then multiply by 100 to get the percentage error. So you notice throughout this topic, many students will find it to be difficult, but you notice it is as easy can be. You just need to classify them, know when you need to get the limits, know when you need to use the percentage as it is when you're given the error. Notice that again, when it comes to, as we discussed earlier, rounding off, truncation, there is going to be an error. So in that case, again, you don't look for the limits. You just take, when you round off, that is the estimate. If it's addition, multiplication, you just multiply directly to get the estimate value. Then if after multiplying, you get the difference between the estimate value and the actual value. Then if you want to get the percentage error, just divide by the actual times 100. Let's take an example before we conclude. You're told that a student got the answer as 1.78, but instead, so let's say measurement, or in our calculations, got the answer as 1.78. Instead, the student gave the answer as 1.8. So this is actual. This is what was expected. This is the estimate. So if you want to get the percentage error, so one, you must get the error, the difference between the actual and the actual and the estimate. So this is 1.8 minus. Remember, we said error cannot be negative. So you can always pick the bigger value minus the smaller value. So 1.8 minus 1.78 to get an error of 0.18. No, 1, 2. This is a 7. No, 0.02. That is the error. So you want to get a percentage error, you take the error, 0.02, divide by the actual. So the actual is what the student should have given as the answer, 1.78, then you multiply by 100. So generally, that is the various aspects or the various areas that you need to understand in this topic, and that is how you approach this topic. As you can see, it's quite short and quite easy. So make sure you practice on the questions attached, take the quiz, and see how well you can do in that topic.